Okay, this video is going to go over types of responses in the time domain. So, for types of responses, there are four major types that we're going to cover. There are free response. So, a free response is the natural behavior the system has without any inputs. It's just like the homogeneous solution. And you know what? It depends on the initial conditions. On the other hand, we have forced response, which is the behavior the system has due to your inputs. So it really depends strongly on our inputs, u vector t. And then we have transient response. That is the part that disappears with time. Sometimes it is the same as the free response, but sometimes it is more than just that. And then our steady state response is the part that remains with time. So let's look at free and forced responses for this first order linear system. X dot is equal to negative ax plus u with some initial condition for x. So if we do a Laplace transform for this guy, we can find out what the Laplace solution is by doing a inverse Laplace transform. This is a similar system that we've gone through a few different times. So we can see that we have two different pieces here. We have our x0 times our exponential, and then we have our other term here that we can't do an inverse Laplace transform for yet because we don't know what u of s is yet. So this first part here, that is our free response. That's what's left if u of t or big U of s is 0. And then our other piece here, that is our forced response. So let's say that u of t is a unit step. So that would mean that u of s would be 1 over s. Well, in that case, then we'd end up with a solution that looks like this. So if a linear system is stable, our free response will eventually go to 0, and we'll only be left with our forced response or pieces of our forced response sometimes as well. So we can see here, this piece right here, this is our free response. This is our forced response if we have a unit step as an input. Now for transient and steady state responses, let's go through with our same solution that we have here. Let's just break it up into two different pieces. So all I've done is taken this part and just applied that 1 over a, distributed it to both terms. And the transient response dies out as t approaches infinity, hence the word transient is used to describe it. So let's say that t approaches infinity. We'll take the limit with respect to that for this entire equation. And what happens is these two exponentials here end up disappearing, and we end up with only this 1 over a term here. So if we break up our equation to group those two exponentials together, and then our 1 over a is separate over here, we can name these two different terms. The first term on the left here, this is the transient response, because that dies out as time approaches infinity. And the other term over here, that's our steady state response. And that is going to cover types of responses in the time domain.